Alright, welcome back to Quadratic Problem Solving Day 2. We're going to be using our calculator almost exclusively here to model vertical motion problems. Vertical motion is any sort of object that is thrown, kicked, or shot, and it's a projectile that always follows a parabola-shaped motion. So we'll be looking through several examples here. I'm going to be working exclusively out of the calculator, but you'll be filling in everything as we go along through the notes. So if you do start to get behind, please make sure that you take the time to pause the video and get caught up before falling further behind, because the explanations are very important. You want to keep up. So pause frequently, keep your notes up to date, keep them neat. And I want to take this opportunity to talk to you a little bit about what I expect when I say accurately model. So if you're going to accurately model a graph of a situation, you're going to need to properly label each axis with a name as well as a specific interval. So if you're going to count by ones on the x-axis, then make sure you're labeling all of those points that you can put on the graph. Likewise, if you're going to count it by hundreds or 50s on the y-axis, make sure that you label those intervals properly. Also, please make sure that you're labeling using proper units. If it's seconds or feet or miles or whatever the case might be, make sure that you are labeling that as well. When you're going to put your graph on the page, it's important that you actually plot the points accurately and not just scribble something there. Go to your table function, find those points, and place those points accurately and neatly on the graph. If you're not going to do that, practice it now. You're going to get to an assessment where it asks you to accurately model, and you're going to leave something off, and at that point you're going to lose points. So please make sure that you're taking the time to practice that now so that we have that adequate practice down before we begin. Alright, into the calculator we go. So I'm going to be following a script with this, and I'll slow it down from time to time so you can see what's actually happening. So here we go. Question number 1. You're going to type in what you see for your equation into y1. You're going to go ahead and graph it. And as it graphs, you'll see that you have one leg, the other leg, but no top. So I'm going to go ahead and set my window based on what I can see. I can see clearly that it's a real-life example, so I set that to 0. My maximum x value doesn't need to change because I could see both legs of the parabola. The scale likewise doesn't have to change either. The minimum real-life example stays 0. And my maximum, since I couldn't see the top, has to change as well. So I'm going to change that to some number that's bigger than 10. And you're just going to have to guess and check until you get good at estimating this. And then I want to change my scale to something more meaningful. So this is what you need to be filling in over here on this side of the graph. Alright, once you've done that, you should get a graph. There's the graph that you see. That's the graph that you're going to accurately model inside of this box here. Use your units here, make sure you're counting. Use your units here, make sure that you're counting appropriately. Use your table values to create this parabola shape on this graph here. Accurately model, please. Alright, the next thing we're going to do is we're going to go through each one of the answer choices. The first thing I'm going to go to is number 1. How high is the ball after 1 second? That's going to be done inside of the table. So go to your table and find that. Notice after 1 second it's at 70 feet. So we're set and ready to go there. Next thing we're going to do is we're going to move on to number 2. It says after how many seconds does the ball go 80 feet in the air? So with that in mind, I'm going to go to y2 and I'm going to put in the number 80. When I put in the number 80, what I'm putting in there is a horizontal line which models what 80 feet in the air looks like in this graph. For those of you who saw that go too fast, I apologize. That's going to be second trace number 5. What we're going to do here is we're going to sort out the intersection between the horizontal line 80 and the parabola, the path of the ball. I want to know when it first hits 80, which is why I'm bringing my cursor all the way over here to the first one. Once it's all the way over there on the near side, that's when I'm able to find the intersection point. The intersection is going to be at 1.225 and 80, and that's going to be the amount of seconds that it takes. Please make sure that you're estimating out to the thousandths place with all irrational answers. The thousandths place, please. All right, the next thing we're going to do is we're going to move on to question number 3. How long does it take to reach its maximum height? So I'll slow this one down so you can see. Second trace. And this time I want the maximum, so I'm going to number 4. Okay? Number 4 means I've got to find the left boundary. Well, my cursor's already on the left-hand side, so I automatically hit enter. Now I'm going to drag that cursor all the way back to the right side. And once it's clearly on the right side of the top of the parabola, I can hit enter again for the right boundary. Now the guess is unnecessary. It'll find it between those two boundaries that you set for it. Okay? The maximum height is 2.5, or sorry, the maximum time is 2.5. The amount of time it took to get to the maximum height is 2.5 seconds, and the maximum height is 106 feet. We'll use 106 here in a few minutes, even though we're not going to use it right now. So store that in your brain. Don't forget about what the maximum height of this graph was. All right? Slow it down one more time so we can see what we're going to do next. The next thing we're going to do is we're going to find out how long the ball was in the air. So I'm going to calculate a 0 here. Now this is not my favorite way to do this because it takes a little bit more work, but I'm going to show you this time so you can see it, and then I'll show you another way in a few minutes. So what I want to do is I want to put my cursor on the left side of where the ball hits the ground. The left side will be anywhere over here, and that's what I'm going to do right now. Alright, so then you go to the right boundary, and once you do that, hit enter, and it's going to give you the 0. The 0 in this case is going to be 5.074 seconds. That's the time it takes for the ball to hit the ground again after taking off. The last thing we want to do is we want to address the domain and range situation. So the domain is from 0, that's the time, till the time it hits the ground again to 5.04. Those are both included, so use brackets in your interval notation. Your range is going to be from 0 all the way up to 106. Remember we said about that 106 there, and that's where we're going to be. Okay? Alright, let me reset this for our next video. Alright, now we're going to move on to question number 2. Question number 2 involves us halving the height of the first ball. So here we go. We still use negative 16x squared, but instead of 80 this time, it's going to be 40, and we're going to use 6. Graph it, and what you want to look for here is you want to look for that parabola's top. And I reset my window screen back to what it's supposed to be. You most likely have not, so you just may need to adjust a few of your numbers just so that it becomes a more clear, easier to see picture, because most likely your parabola is very small inside of your viewing window right now. I went ahead and reset mine back to the 10 by 10 window so that it's easy for you guys to see how I change this each time. So I'm using some estimates here to figure out where the possible best viewing window is going to be. Alright, so here's the good viewing window where you can see your graph. And then we are going to go into y equals and just put that 0 there and figure out where it is that this ball hits the ground. So notice I have a red line on the x-axis, and I just calculate their intersection. Just make sure your cursor is closer to this one rather than that one, and it makes it easier for you to find the answer. We're using this to find the domain. Notice that I just found the intersection, and see how much easier that is than calculating the 0. It is completely up to you how you want to do that. And now let's go ahead and determine the range. Again, that's going to be number 4. You're going to find the maximum, number 4, maximum. And once you do that, you want to move that cursor back all the way. This is going to take forever, I'm sorry. Back all the way up to the left side, then back again to the right side. Hit enter, and you'll find your maximum there. It is after we find this maximum that we can actually answer question number 3. So you should be filling in your domain and range right now, 0 to 2.642 included, and your range is going to be 0 to whatever this calculation has become. So undoubtedly you're able to do this faster than this script is able to do, so you should be able to have the answer already. And I've got 31 as my height. And the answer to that would then be, of course, no. All right, we're going to move on now to question number 2. And this will be the last one that I go over with you, so that you can do the rest of these on your own and have that ready to go at the beginning of class tomorrow. All right, script number 3 is going to involve this submarine. And we're changing from feet to meters here. And since it's underwater, we're going to see a little bit of a different type of parabola once we change our window. I'm going to change my window screen. And I've just been able to do the guessing and checking off of script, so it makes it a little bit easier to see. Notice the minimum has been flipped here because we're underwater. All right, and then here is your graph. Accurately model this, get into the habit of doing that. Make sure you've got this very nice parabola on your notes tomorrow. We're going to find the minimum value now. Minimum value is number 3, not number 4. But it's still found the same way. That's why I didn't slow it down. Let's go ahead and just get through this so that we can see how to get all of these values. There's your minimum there. Again, if you're not getting these, please make sure you're asking these questions. Slow the video down, replay it, so you can get these calculator functions down. Make your life easier. All right, we're going to find the place where it is 4,703 meters below the sea level, and we're going to find both of those. So the first one's very simple, just enter, enter, enter. And the second one we have to do again, but this time we got to move that cursor all the way over to the other side. It's so slow. So that first one, I know it went by pretty quickly, was 44.996 seconds. And this one here is going to be, dun, 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 wait for it, 21.330 seconds. All right, and then you set your domain and range from that. Very simple, very straightforward. It would be 0 to this time right here, and 0 to this depth right here. So we're going to go ahead and go back through that one more time so you can see it. I'm going to change this back to 0. Once I graph it, you'll be able to see on my screen how the red line shows up on the x-axis. Then you want to find the calculation of the intersection between those two. Remember, the only thing you have to do is make sure the cursor is closer to the 0 you want to find, and that's going to be the way for you to quickly find the root, the 0, the x-intercept, in this case, the domain, when the submarine reaches the surface one more time. All right, I'd like you to go ahead and solve the remainder of the problems on your own. That's only question 3 and question 4. What I'd like to do, though, before I stop the video, is I'd like you to give you a chance to understand what the vertical motion formula looks like. And this is going to be negative g x squared plus v sub 0 x plus h sub 0. And then this gives you the information that you're going to need in order to solve this. Remember, this is feet per second squared, or feet per second. So in order to get these in terms of gravity, we've got to divide both 32 and 9.8 by 2. So if you're using feet, the gravity coefficient is negative 16. If you're using meters, the gravity coefficient is negative 4.9. Why negative, you say? That's because gravity pulls us down in a negative motion according to physics. So that's why we're using that mathematically. Like I said, please solve questions 3 and 4 on your own right now and have those ready to present or share with your group mates tomorrow so that we can do the activity quickly, efficiently, and you guys can get some more practice with vertical motion.